In this video, we'll talk quickly about Venn diagrams. Venn diagrams are just a nice, quick visual way to represent groups or sets. Usually we just draw them as a series of circles. There's some new concepts: union, intersection, neither, and complementary. There's going to be some symbols for those and some notation that goes along with those, and we wouldn't have come across those before, so it's going to be a bit of a new thing. Union is represented by the symbol just U for union, and this is the OR situation. So we have two sets. We'll talk about only two sets in these examples: A or B. So A union B is everything that's in A and everything that's in B and anything that overlaps. So in this case, it's all the yellow part there, all the blue part, and all the green part. Intersection is an N for intersection. It's the symbol here. This is the case where we have AND, so it has to be in both sets. So it has to be in A and B, so it's the overlap. So in this case, it's the bit that's in both sets there, that's shown there in red. That's the intersection of A and B. Neither is sort of just like it sounds. If we have two sets, A and B, it's everything that's outside of A and outside of B. So here it's represented by the light blue bit that's outside of A and outside of B. We also have complementary. It's represented just by a dash to go along with the letter, and this is the opposite. So if A is the circle, A's complement is everything outside of the circle. And you see A complement here being everything that's green. There's also a couple general principles that go along with this: total probability, mutually exclusive, and intersecting events. Just some principles that we need to remember when we're making some calculations. So the first is total probability. So if we think of A as rolling an even number on a die, and A's complement then would be not rolling an even, so of course the probability of those two events occurring, one or the other, has to happen. That's where we get the probability of A and probability of A complement being 1. So with the picture, you're going to see it as everything that's in A, the purple bit, and everything that's A's complement is the yellow bit. So it's the entire bit there, everything that we're talking about. Mutually exclusive events. This is when there is no overlap. So A is one set, B is another set, and this time the circles themselves aren't touching. So the probability of A union with B is just the probability that something's in A, and add to that the probability that something's in B. So here we're looking in terms of the areas of the circles, the yellow bit there, add on the green bit there, and that's going to be the union of the two when they don't intersect. Intersecting events, there is some overlap. So it's everything that's in A and everything that's B. You notice there that equation there, you've got minus A intersection B, probably A intersection B. That's because we don't want to double count. So we start with the yellow bit, everything that's in circle A, add the blue bit, everything that's in circle B, but we subtract that bit that's in the middle, the intersection of the two sets A and B. Otherwise we would have double counted that. That's why we're subtracting it. We've already counted it twice, we have to get rid of it once. Then we're going to have the probability of A union with B. And that's it for this video.